my YouTube channel. And today we will be doing factory design pattern of low level design. Okay. So before starting this video, I hope you have seen my strategy design pattern because this is based upon that only. We will be moving forward from where we left in that video. Okay, so let's get started. Now, if you remember strategy design pattern, we have solved a basic problem of defining a strategy everywhere whenever we need. So why do we need factory design pattern? Okay, before going to know, let's see what problem we can face in strategy design pattern. Okay, so now if you remember our strategy design pattern, so we have created one drive strategy and we have extended it to two different strategies, which was two-wheeler strategy and four-wheeler strategy. And we use two-wheeler and two-wheel vehicles and four-wheeler strategy in four-wheel vehicles. But now, what if some problems comes where you have to define and the strategy based on some requirement, and maybe the strategy can change based on different scenarios. Maybe there's a vehicle who can drive in two-wheeler manner as well as four-wheeler manner based on some requirement. Okay, so what in this design, what the problem is in Scooty, we have hard coded that it will always use two-wheeler strategy, which can change. Okay, so this is a uh, very problematic because if Scooty want to use four-wheeler strategy, it cannot. We have to come and hard code again and then redeploy our changes, which is not a good approach. So that is why factory design pattern came. So in factory design pattern, by the name it suggests, it holds all the type of strategies which you can have. And based on certain parameters, it will return you the strategy which you want to use. Okay, so let me show an example. This is what a factory looks like. So this is a drive factory where we have both two-wheeler and four-wheeler strategy. Let me correct this one. Okay, yeah. So we have both two-wheeler and four-wheeler strategy, and we have one get strategy function, which where we can pass certain parameters. For example, I have passed type here, and based on this type, we will then return a factory. This factory will return a strategy which will be used further for your code. Okay, so this in this get strategy we can pass whatever parameter which we want. Also, this can return you the strategy which you want to use based on environment variables or some config variables. Anything, any type of logic you want to implement, we can implement in this get strategy. And what we have to do here is now we don't need this strategy here. We need a factory here. Okay, and we will it will be a drive factory. And now when we want to call our drive method, we'll be calling something like this: factory dot get strategy dot drive. So this is a more extensible and more scalable code which you can extend if you want some other, if maybe some other strategy comes, and if you want to do, we won't don't want we don't do any change here now in Scooty. What we'll do is we will add one strategy here, and based on requirement, whatever we want, we'll start sending it from here. So everywhere where this parameter will become true, our new strategy will be used. Okay, so I think this is more scalable. And why am I telling this to you? This is a short video because I will be using only these two design patterns to solve a problem which came in phone based machine coding round. Okay, and so you'll get to know that these two design patterns are very much asked in most of the interview questions, and how to implement these, I'll let you know in the phone in that machine coding interview problem when I'll explain in my next video. So Till then, stay tuned and wait for my video.